welcome back. In this video we're going to go over the factory lighting systems, how they function, where the power comes from, some common issues, things of that nature. We'll get back to the headlights as well. We'll talk more about headlights, and then towards the end of this video we're going to mess around with some headlight relays and explain how to do that and why it's a good idea. Kind of related, we're going to talk about this guy. This is a time delay relay, and it was usually associated with a lighting option on most of these cars. Some of the C-body cars, it was a factory standard option. But we're going to show a little bit about how it works. It gets its power off of the unswitched power tap on the harness. Typically on this pink wire, this is unswitched voltage. There's a lamp typically, as I move it over here, there's a lamp typically in the steering column that lights up the ignition switch. Some of the E-bodies, there was a tidal lamp above the headlight switch that also was a part of this circuit. And when you open the door, the yellow with the black tracer wire here went into the door switch circuit on the dash harness. And when you open the door, the timer engaged and turned on that ignition switch lamp. Once you close the door, like you're preparing to start or something, the light will stay on for a few seconds. It will depend on how long the door's been opened, exactly how long the light stays on its own. But if you don't do any other function, the light will go out. If you are working on the car and you have the door open for a prolonged length of time, these guys can get a little warm. It's normal. That's how it worked. Speaking of how it worked, let's take a peek here. There's our little bimetal electric switch. In this case, in a normal idle state, the contacts are open. I don't know if you can see that in the camera or not, but when we ground that through the door pin switches, we're going to heat that up, and it's going to close those points and turn our light back on. And if we watch it again, you'll see it cool off. It should open that contact off. It should open that contact up. Can't see the light. The hand's blocking the light. There, it's open now. Anyhow, that's how that guy worked. That's what that was for. I see that question come up a lot. What is this weird looking little round thing hanging off my dash harness? It's a time delay relay. Again, most cars, it was part of a lighting option, and not all cars have them. Headlight switch. Headlight switch gets power from two different sources. If you've watched the other videos about power distribution, you'll know that our primary headlight power is a 12 gauge wire coming off of splice 1. There's a second power source here referred to as B2, this pink wire. The pink wire comes from our unfused wire tap we were just looking at a minute ago, and from that pink wire it goes off and gets its power from this red wire, running over to the cigar lighter plug, turning around the red wire goes back to the fuse panel, and there's a fuse in the fuse that protects this. So basically how that works is that provides power to running lamps, parking lights, and dash illumination lights. If you have a headlight switch with a dimmer or a rheostat built into the switch, this power for your illumination lights also comes from that fuse. Adjusting the rheostat will adjust the voltage going to your dash illumination circuit through a tan wire exiting this switch. The tan wire runs back to the fuse box. Guess what? There's a fuse there for that. A little 5 amp fuse typically. Turns right around and comes out of the fuse box as orange. Usually the dash illumination circuit are orange color coded wires. Pretty consistent. In this particular cluster, it routes around to individual bulbs. There's also a tap on that for accessories that may need some illumination circuit access. On these particular cars there were some optional switches under the dash, rear window defogger, like an air grabber switch or something like that that mounted to the bottom of the cluster. They also had a light that kind of shone down through a hole onto the switch, so that was illuminated. But that would have an extra lead that actually connected into that guy. Power up all that stuff. The other aspect of this is the running lights. This is the park or running lights, whatever you want to call them, also coming off of that pink wire. So you pretty much have all your running lights, your cigar lighter, anything you have plugged into this unfused option tap, all that's going to be on a fuse over here. If you lose your park light, if you lose your running lights, you're going to lose these other items as well. Or for that matter, somehow you experience a short in your cigar lighter, you're going to knock out your running lights and your dash illumination. That's basically how the headlight switch works. Again, we have our halogen seal beams over here. We're going to get into the weakness of this headlamp system here. If you were watching some of the earlier videos in this series, we showed that there's some heat building up on these wires with these headlamps. These are just a tad more current drawing than the original seal beams. Half an amp maybe per filament. Numbers are about 5 amps for the original stock seal beams. On a 4 lamp system, the 2 filaments of the low beam equaled about 5 amps. This is about 6 amps for the sealed beam halogens. These are the more modern replacement to the original sealed beams. You just can't get the originals anymore. And on high beams, you're going to knock that number up to about probably 14 amps, something like that. We were taking some measurements. Actually, you can see it. We have our ammeter set up to monitor the current. At this point, the engine is not running, so this current is being pulled from the battery side. There should be an indication on our ammeter, and there is, that current is coming from the battery. Important to load this system correctly. When we get the engine fired up and get the alternator functioning, you'll see that the discharge went away on the ammeter. We pulled the battery down a little bit a minute ago with these lights being on. Kick that back down on low beam for the time being. Some charging going on here, but most of that current for that headlight load is coming from the alternator. We talked earlier about some of the earlier videos about what kind of stress that puts on Packard terminals there and what can be done to make a better connection at the bulkhead connector. And we're also going to get back into more talk on how we can get around the bulkhead connector altogether with this type of load, and how we can get the load off of these original 16 gauge wires. We did some thermal imaging of these wires in one of the earlier videos in this series. I'll put some of that video back up, but these original 16 gauge wires just cannot handle this type of current in a long-term situation. And there's quite a bit of voltage loss through this wiring, through these connectors, through the bulkhead connectors associated with the headlight wiring. We're gonna put relays on here and resolve this issue. We'll get to that in a sec. I think that about covers for the overall operation of the system. Let's get some relays going here and take some more thermal images. Stand by on that. Installed some relays on the headlights, and I've wired them. I'm drawing my secondary power off the starter relay or the battery. It doesn't really make a difference. As many who promote this tell you to do, that's a problem, and I'll demonstrate why that is. When you do this, you're simply taking the current the lamps were pulling off of splice 1, where it should be loaded on the alternator side of the ammeter, and you're placing it on the battery side of the ammeter. While the car is not running, the power is going to be sourced from the battery. If you watch our ammeter over here, we're going to turn on our park lights. We got a little bit of discharge going on with these lights that are lit up currently. And turn my headlights on. This is high beams. That should be 14 amps of current. There is 16 amps of current being pulled from the battery currently. What's going on here? Our ammeter is not showing that at all. So what's the problem? The problem is when you start the car and run the alternator, that power is coming now from the alternator, not the battery. You can see the current coming off that alternator output wire. And you'll also notice we have a great deal of charge indication going on here. That's not charging, that's this 14 amps of headlight current now coming from the alternator through the original stock wiring, Packard connectors, Price 1 ammeter wires. Ammeter itself now has this current stress placed on it for however long you're running down the road with these lights on. That is not the correct way to do that. Stand by 1 sec. Okay, we're back after reconfiguring where we're getting our power from. When doing this headlight relay modification with an ammeter in the dash and you're still running the original ammeter, that power has to be on the alternator side of the ammeter. If you don't want to overstress the stock wiring, stock ammeter, and any other components original to this charging system. We'll try this again now. Key off, headlights on. Now I'm seeing my discharge. That's normal. Power is coming from the battery, key off, but it's going through the charge and distribution system ammeter back to the battery. Let's power up the car, get the alternator functioning. Again, we're seeing a little bit of charging. We're seeing 6 or 7 amps of charging. I have a total alternator output over here about 23 amps at the moment. I'm on high beam. But none of that current, the headlight current, is now flowing through the stock wiring. Current flowing through the stock wiring under these conditions would be the current required to trip the primary coils of these relays. Very little. Maybe 150 milliamps are now flowing through these wires. Where before we had the full lamp load running through these wires, the switches and the connections, Packard terminals, all of this has been reduced to almost nothing. There's no wire warmth at all. I'm going to get an infrared of this. I'll put that up in a second and we can have a look, see how this relay addition altered the thermal footprint here. We'll note too, I'm running two separate power supplies to these relays, one for high beam, one for low beam, and two separate fuses. This is redundancy. If something goes wrong with one of the lamps, high beam or something should short, or wiring to a headlight should short, it'll only take out that particular circuit, and I still have the other lights to get back to. I typically do auto resetting circuit breakers here. There's no real need to do fuses, but fuses will work. So that about covers lighting issues on this original electrical system. I do have a turn signal switch connected to our connector for left side only. Just kind of see how that works. Make a left-hand turn. That closes the circuit from the bulb load. This is the bulb load going out to the lamp. The one filament that's the higher wattage filament. The other one's the Park one. And that load is what triggers the flasher to start flashing. And power for the flasher, as we said in one of the early videos, comes from the radio fuse in the fuse box via the plug at the radio. Another common issue that I've run across over the years, people buying new cars, well, not people purchasing these old cars, can't figure out how to get the turn signals to work. Someone's cut off this radio connector and did not reconnect those two wires together. It comes up fairly often. Make sure that your radio connect. If you're not using the stock radio, aftermarket radio, be sure you get these two wires back together again. Videos going forward, we're going to talk about some modifications to this system to beef things up somewhat and be able to run more loads, run a higher output alternator, and retain the ammeter and the basic function of the original system. So let's look at the infrared for the light wiring. High beam's on. We'll watch the temps on that stock 16 gauge wiring. Once more, those are sealed beam halogens. A little bit more current draw than the original seal beamed in a 4-lamp system. But you'll see pretty quickly that those wires heat up pretty quickly. That's the foot switch for high-low. You'll see the connectors at that switch are also showing signs of resistance and heat. And that's our little light green wire coming off the headlight switch there. That connector right there is building up some heat. Wiring from the harness, the dash harness, runs out to the bulkhead connector and from there out to the lamps. These are the wires back here running out to the lamps. And the temps get kind of high. Yeah, no good. That factory wiring is way insufficient. We'll switch over to the relays here in a sec, and we'll see what the wiring looks like with the relays in place. And again, high beams, those are the relays themselves right there. Same wiring is right in this area here somewhere, and they're not even showing up. Let's look at some headlight current draw comparisons. Did this comparison a while back in relationship to Holley Retro Bright LEDs and how much current those draw compared to what would have been conventional headlights. Numbers are interesting here. Original sealed beamed headlights on a 4-lamp system pulls 5 amps with the low beam selected, and on high beam we're pulling a total of 12 amps. And then the seal beam halogens, 6 amps and 14, we saw that a minute ago. But to get into some high wattage headlamp systems on a 4-lamp system, we get into some pretty serious numbers here. And there's no way to run those through the factory wiring. And interesting, we get down here to the LEDs. Yeah, they pull a little bit less current on the low beam side. We're pulling 4 amps on low beam on a set that I measured. High beam total of 12 amps. 12 amps is the same number we had for the original sealed beams, and some percentages of how much less the LEDs draw. The numbers get pretty big when we're talking about these high watt conventional headlights, but it's pretty close to the original sealed beam lights. You still need to mess with some relays here if you want to have these things be reliable.